Okay guys, so now the next video is based on calculations based on balanced chemical equations. An example I've chosen is on page 172 and it's question 34. The reason I've picked this question is because it actually does a little bit of everything in it. They're looking for mass, they're looking for volume at STP of a gas, and they're also looking at a number of molecules produced. So it's a really good question to kind of tick all the boxes. It's kind of a so we figure out what we're doing. So the first thing you do is you write out your balanced chemical equation. That's the first thing you do. After that then is the important thing is you have to get your ratio. Okay, so you have to put in your ratio. So the ratio here is 1 is to 1 is to 4 is to 1. Okay, and just for those of you who don't know how I got the ratio, it's basically the number in front, the coefficient in front of each of these. Okay, so none of them, bar the water, have a coefficient in front of them. So we assume it's 1. It's just like x is the same as 1x, that kind of thing. So that works out as our ratio there. Now, they tell us in the question that we have 31.5 grams of the ammonium dichromate here. Okay, now there's 3 things they want us to do. They want to find the mass of chromium trioxide, they want us to find how many water molecules, and they want us to find the volume of nitrogen produced at STP. So they give us the grams, that's great. First thing we have to do, convert that into moles, and we divide it by the mass of the ammonium dichromate. Okay, so that's 14 plus 4, okay, is 18 as such. You multiply that by 2 is 36, plus 2 times 52, which is the mass of the chromium, and 7 times 16, which is the mass of oxygen. That gives you a total of 252. Okay, and then you divide your 31 by 0.5 by that 252, and you end up with 0.125 moles. Now, when we have that done, we have to get our new ratio. Okay, we have to get our new ratio. So we have, instead of having 1, we have 0.125. So everything's based off that. That 0.125 now constitutes 1 in our ratio. So it's 1 is to 1, so 0.125. 0.125 is to 4, so we have to multiply that by 4. Okay, is to 0.125. Okay, so that works out, the 4 times 0.125 works out as being 0.5. Now, I'm just going to cover these because I'm going to answer the 3 separate questions individually. The first thing to ask is the mass of the chromium trioxide. Now, the mass of chromium trioxide is 152. So what we do is multiply the 0.125 by the mass, the relative molecular mass of the chromium trioxide, which in this case is 152, and that gets us 19. Okay, so for mass, you just, once you have the number of moles that you should be getting, you multiply it by the relative molecular mass of the species, and you get whatever you get. In this case, it's 19 grams. Okay, the mass is the only one that changes. If they're looking for the number of particles, like they are in the next one, well, the 6 by 10 to the 23 doesn't change. Okay, the 6 by 10 to the 23 doesn't change. So 0.5 by 6 by 10 to the power 23 is this. So that never changes. What also never changes is when we're talking about gases and the volume that's produced at STP. So in this case, it's 0.125 moles, okay, times 22.4, which is molar volume at STP. If they asked at room temperature, guys, it's often given at the start of the paper. If they're ever asking anthem in a gas at room temperature, it's usually 24 litres is molar volume at room temperature. But anyway, it's 0.125 times 22.4 gives us 2.8 litres. But as I said, if they're asking for room temperature, it will be on the front page of your exam paper. Okay, so always be careful of that, okay? So in this case, guys, we started with our balanced chemical equation. We got our ratio. We took the information they gave us here, which is mass, and we converted it to moles. If that was, let's say, a gas and they gave us litres, for argument's sake, you convert it to litres. Again, this is all just mole map stuff. So we've converted it to moles. Okay, then we get our new ratio based off this new information. Okay, and then we basically, once we have this, we answer any of the questions they ask us. So in this question, they asked for mass. In this question, they asked for number of particles. And in this question, they asked for the volume at STP. Okay, so all the next ones we're going to do, guys, are based off this ratio, converting, new ratio, and going from there. Okay, so keep that in mind when we're doing the rest of them. Okay.